Hi, my name is Ashley Lieber. I'm a junior here at the university, and this is my research partner, Logan, who is a senior. The purpose of our project is to study the classification and behavior of the variable star B1719 Cygnus. A variable star is a star that varies in brightness over time in a very repeatable and predictable way. Variable stars have historically been very useful in determining distances to stellar objects. This star in particular is very interesting due to its abnormal characteristics, including its light curve, which my research partner will elaborate on.
This star has been studied before, and it was classified as an R Lyrae type variable star. But later, since it's been studied again, there's been some discrepancy, and some people say that it should be classified as a Delta Scuti type star. This discrepancy isn't super surprising because these two types of stars have some very similar characteristics, which can be seen in Figure 3, an HR diagram, which is just a tool astronomers use to look at some characteristics of stars, specifically their temperature on the x-axis and their luminosity on the y-axis. You can see the R Lyrae stars in the orange or yellow circle and Delta Scuti stars in the green circle are pretty close together, and so they're going to share some characteristics there, as well as having some overlapping periods. But it is really important that you classify a star as the right type of variable star because each type of star has a different period luminosity relationship. And that relationship is what you use to estimate the distance that Ashley mentioned earlier.
Yeah, so through the help of our mentor, we were able to partner with the Our Solar Siblings project based out of Australia. Through this, we were given access to the Las Cumbres International Telescope Network. We were able to put in our parameters for our star and to remotely request data from a telescope. Based on the location of our star in the sky and the time of year, we used the 0.4 meter telescope located in Hawaii, shown there in Figure 1. We took our data starting in November of 2019 all the way up until March of 2020. You'll see there in Figure 5 in the lower panel an example of one of the pieces of data that we received. We took this data and we ran it through a series of Python code that compared the variability of our star as it became brighter and dimmer over time as compared to the relatively constant background of stars around it. You'll see there in Figure 2 the depiction of this variability. We have an example from the B and Z band, which is two just different wavelength categories. On the y-axis, you'll see the magnitude, and on the x-axis, you'll see the phase. It's graphed two cycles of the period for us here. And you'll see that this is rather abnormal because it's not symmetrical across its period, which is what we would normally expect for a variable star. The rest of our data in the other bands is shown there in Table 1.
This data in Table 1, specifically the period and magnitude, was then used with the period luminosity relation that I mentioned earlier to make a distance calculation. These calculations are shown in Figure 4, with calculations being done for each relation that we have. They're different not only for the type of star, but also for the band that the period was found in. So we have the R Lyrae stars, distances determined in the V, I, and Z bands in orange, but for Delta Scuti stars, a relation has only been established for it in the V band, and that calculation is shown in green. These can all be compared to a previous determination of its distance in the literature, which is shown in the blue bar.
So we took data in 4 bands, and we got the period in each of those 4 bands, but the average of those periods we determined was 0.269 days, which is about 6.5 hours, with an error of about 45 minutes, give or take. This determination is very close to previously determined results, the most recent there in 2002. This evidence further supports our claim that this is in fact a high-amplitude Delta Scuti type star.
More evidence that it's a Delta Scuti type star is that the R Lyrae distance determinations across the different bands do not agree very well with each other. We'd expect them to be really similar if it was an R Lyrae type star, but they vary almost 100 parsecs from the V to the Z bands. And then the calculation using the relation for Delta Scuti type stars agrees most closely with the literature's determination of the distance. So moving forward, we can use the measurements of the periods in these other bands to better understand the relationships between period luminosity. and distance for Delta Scuti type stars.